Example number 8, we will apply the chain rule for this problem. The outside function is f of x is square root of x, and that will be f of u square root of u, and the u will be the gx for later, okay? And gx is the one that plug into the function f of x, so it's equal to secant of x cubed. And we keep in mind that later the u will be the g of x when we write out in the result. Then we take the derivative of f and g. So f prime of u is u to the 1/2 prime. And we apply the power rule, so 1/2 u to the 1/2 minus 1. And 1/2 u to the negative 1/2. So that will be 1/2 square root of u. And g of x prime is secant x cubed. So secant x cubed, and again, this will have to be the chain rule. Okay, so let's just write out in this step first. Then we'll apply the chain rule for g of x later. Now y prime is 1/2 square root of u times secant x to the 3rd power prime. We plug in for the u, so 2 square root of u is g of x, so secant x cubed. Now we will do secant x cubed prime. Then we do chain rule one more time. The function f of x is the most outside one, so it has to be secant x. And g of x will be x cubed. Then we're going to change for the u. So g of u is secant of u. And later on, this u will be replaced by the g of x. And if you want to be different from before, you can make it like 1, okay? f1 and g1. Then we take the derivative of f prime of f1 prime, secant of u. The formula we learn is secant u tangent u. So we look the one we learned in the section before in the green color, okay? And then g prime is we apply the power rule, so 3x squared. Now we multiply secant u tangent u, multiply f and g together, times 3x squared. Now we replace the u, so I'm going to write 3x squared to the front, and then 2 square root of secant x cubed. Secant u will be replaced by the g1, so that will be 3x squared and tangent of 3x squared.